Welcome to the video walkthrough for our latest and last of the mock assessments, Key Assessment 4. Let's see how we did. So, easy start for us. Question 1. And it's match each box on the left to its correct unit on the right. So we're looking for the basically what we would use for each of these. So a unit of length, we can rule that out. We've got second, metre, litre or kilometres per hour. So I'm going to go with metres. For time, we're going to go with second. And for speed is kilometres per hour. Okay, so that's the three we're after for that one. Then we've got a centimetre grid, and it tells us there are 3 points on the centimetre grid and we want the coordinate of point A. So of course it's here, so it's along the corridor and up the stairs, so it's 2, 3. And then it tells us that A, B and C are the three corners of a rectangle, and we need to work out the area of A, B, C, D. So we can go along here. We can see that our fourth corner should be there, which gives us a badly drawn rectangle, but you get the idea. Now, you can work it out. You can do 4 times 2, or because it's a centimetre grid, we could just count how many squares are inside. Either way, our answer is going to be 8, and that goes down on the bottom there. Okay, there's question 2 done. Question 3, we're into sequences, and it's just linear sequences, and each one is 1 mark. So we don't have to worry about nth term at the moment. See what it's going up by. In this case, we've gone up by 6 each time. So we add 6 onto 28 and we get 34. For the next one, we're reducing, and each time we're going down by 11. So we need to take 11 off 7. So if we take 7 away to get to 0, we're left with 4. So that's going to break us down into -4. Then the last one is sequence of triangular numbers. Hopefully you've gone over these before in class, but if not, I'll just do a quick reminder for that one. Start off with 1, then we've got 3, so we can now see we've got 3 dots there. Then we got 6, so I've added another 3 on, and then we go to 10, so I've added another 4 on, and you can see the shape there is our triangle, and each time we've added another 1 on. So in this case, here we added 4, so here we would add 5 on, and 10 plus 5 gives us 15. Okay, you don't have to show that, that's just to help explain it if you haven't gone over it in class before. Question 4, ticking a statement for ticking a box for each statement below, and we're talking about a cube having 8 vertices. Now vertices are corners, and a cube does indeed have 8 corners. It says here triangular prism has 6 faces, and that is not correct. So it's false for there, because we've got the 3 around it. If you think of a Toblerone box, we've got the 3 main sides, but then there's a triangle on each end. It only has 5 faces. And a triangular base pyramid has 6 edges, and that is true again, because you've got the 3 around the bottom and then the 3 as it comes up to the point on the top. Question 5, probability, still only 1 mark. Okay, so nothing too nasty. We've got 100 cards for a game, and 7 of the cards are winning cards, and we want the probability. Well, if there's 7 winners, we've got 7 out of the total, which is 100. And that's all we're after. Okay. Now, if you changed it into a decimal, you could have 0.07, or you could have 7%. Either of those would get you to the point, but that's the easiest one. That's the one I would go with. Question 6. Translations. So this rectangle is translated 4 squares right and 2 squares down. Now we're used to seeing that as a vector. Okay, so 4 squares right would be a +4, and 2 squares down would be a -2, and we know we're going to the right and we're going down. Okay, so I'm going to show you 2 different ways. Now if I do this, now if I was to do this, tell you what, we'll go from that corner. If I pick that corner, and I'm going to go 1, 2, 3, 4 across and 2 down, I might then think, well, my shape doesn't fit on. And that's because we're not matching a corner to a corner. That bottom right should be the bottom right there. So if I do the same for this one, do the top right, 1, 2, 3, 4, and down 2, and I can see that is where that side is. And I'll do this bottom one, bottom left, 1, 2, 3, 4, then we're down 2, and we are there. Now we can see more or less where the shape is. I always say do at least 3. So if I carry on that one, and we've got our shape there, and I'm going to draw that in, and that will do us nicely for that. Okay, now not everyone's comfortable with that, so the other method is use tracing paper, trace your shape as well as you can, and then again we just move the whole thing across. So we're going 1, 2, 3, 4 squares, and then down 2, and we've ended up in the same place. Okay, so either method works. And of course, if you haven't got tracing paper, they're not being given out, and you think you need some, certainly for a question like that, ask for some. Okay, request it. I'd rather have the request in, and if they get you some, than not doing it. Okay. Now here, completing the table, we've got fractions and we've got percentages. Okay. So if I'm going to change a fraction into a percentage, if I put my fraction on the calculator, so I've got 7/8, which is what we've got there. Now at the moment, if I press X, it will give me the decimal, and of course to change the decimal into a percentage, I times it by 100. So I'm going to do that all in one go, and that was going to give me, well, it gives me a fraction straight off. So of course on the new calculators, press format and then move down to decimal, and then we'll get our answer, and it's 87.5. so that is 87.5%. And then to change, we want to look at percentage back into fraction. I always say to you, basically, if you change the percentage into a fraction, put the percentage they give you over 100, and then simplify. Again, we've got the calculator. Let's let it do the hard work. So I've got 150 over 100, because we always measure percentage out of 100. I press it equals, and I've got 3/2, and that is all we need. So 3/2. Now I started off with 150 over 100. So either will get you to the point, because they didn't specify you had to simplify. Okay, so either will be okay there for me. So, then 7b, prime numbers. Write down 4 prime numbers that are less than 10. I'll tell you straight off, if you put 1 on there, you've lost the mark. Okay, 1 is not prime. A prime number has 2 factors, 1 and itself, whereas 1 can only be divided by 1. The first prime is 2, and it is the only even prime, because every other even number can be divided by 2. So we start off with 2, and then that gives us 3, 5, and 7 for the rest of them. Okay. So just be careful on primes. 1 is not prime. So, question 8. We've basically a bit of a meal deal, but unusually for this type of question, normally you've got 2 offers and you're working out the best version, but this is the case of sandwiches and drinks, and we just need to work out each deal. So Tilly's buying 4 sandwiches and 3 drinks. Now sandwiches £2.50 and all are half price. So £2.50 divided by 2 means that each of the sandwiches are £1.25, and I can now do £1.25 times 4, and that's going to give me, well, here we go, let's go through it. 4 times 5 gives me that, 4 times 2 is 8 plus that, and 4 times 1 is 5. Sorry, 4 times 1 is 4 plus the 1 is 5. So we've got £5 for the sandwiches, and then the drinks, they're £1.60 each, but we buy 3, but we only pay for 2, and we're after 3. So we're only paying for 2, so we just need to do £1.60 times 2. So I can do that. and 2 times 6 gives me 12, so we'll carry that 2 times there, so I've got £3.20 for my drinks. Add the two together and we end up with £8.20. Okay, I'll show that anyway because it is a 4-mark question. So we've got £5 plus £8.20, sorry, what am I saying, £3.20. I'm jumping to the answer already. Okay, and that basically we cover all the bases there. Okay, question 9. This time we're buying apples and oranges. We know the total cost is £5.30 and we know the cost of the apples. So I'm going to deal with this now. Now, they're asking us for 1 orange and it says give your answer in pence. So I'm going to do the easy bit. £5.30 equals 530 pence. I'm just going to work in pence on this one now. Some of you may have worked in pounds and then changed it. That's fine. You will still get the marks. Okay. So apples cost 42 pence each, and we're buying 9 of them. So if I do 9 times 42, I get 378 pence. So 9 times 42 gives me 378 pence. I can now take that away from the 530 pence we've got before. So 530, take away 378, and that leaves me with 152. And that's 152 pence, and that will be the cost of the oranges. So all I need to do now is 152 divided by 4. So again, I've got my answer still on the screen there, so I'm just going to divide that answer by 4, and I get 38. And that is 38 pence. And they've already got the pence on the answer line there, so we're okay with that one. Okay. Just be careful, don't be, because it's in pence, I don't want to see any pound signs up on there or anything like that. Okay, let's make sure they know it's that we've done it in pence. Now we're into question 10. We've got a hotel with 120 rooms, and we know that 20% of those rooms need clean towels. And we're going to put 4 clean towels in each of the rooms, and we've got 85 towels. We need to find out how many more we will need. So they're not telling us, they're not asking will we need more, they're saying we will, we just need to find out how many. So we want to find 20% of 120. Now you can do the usual, stay with it. 10% of that is 12. We can double that to give us our 20%. Or we could do, well, 20% as a decimal is 0.2 times 120. Let's show that on there. So 0.2 times 120, and that gives us 24. So 24 rooms need towels. So I'm just going to put that there, rooms. You don't need to write that, it's part of the explanation. So we need 4 in each of those rooms. So 24 times 4. So again, I've got my answer still up there, so I'm just going to multiply that by 4. I get 96. So that means I need 96 towels, and I already have 85. So I can do 96, take away 85, and again my answer's still there, so I'm just going to take away 85, and that leaves me with 11 towels. So we are 11 towels short. So our answer there is, on the bottom line, is just 11. Okay, like I say, don't need to write those bits. I'm doing them as part of the explanation. Question 11, quick 1 marker. So at traffic light, cars either turn left, turn right, or go straight ahead. And that is the order, left, right, straight ahead. So if we look at these, it's left, right, and straight. So with the modal direction of cars at the traffic lights. Now, when it's modal direction is the mode, okay? It's just up for the modal class. Basically, it wants the description rather than the number. So there, we're looking for the one that appears the most. We've got 3, 8, 7, so it's turn right. And that's all that one is, okay? For these, we've got a table showing types of milk and the percentage of fat in each. And we want the percentage of fat for the 3 types of milk as a ratio, and they've given us that there. Okay. Now, generally, we don't like decimals as part of ratio. Only generally when we're talking in a ratio in the form of 1 to n or n to 1. But that's a different question. On this one, we're just going to change those into whole numbers. And the easiest way, basically, we only need to, they're only going to one decimal place, so we just times them all by 10. So that's going to give me, so 3.5 becomes 35, 1.8 becomes 18, and 0.1 becomes 1. And of course we can't simplify that any further. Okay, so there's our whole numbers. And if you've got your percentage signs on there, that's fine, they don't mind. It's just making sure we've got those numbers. So then we've got a bit of algebra. They're saying A is half of B. So that means A equals B divided by 2. They say B is 1/3 of C. So that means B is equal to C divided by 3. And we know that C equals 30. So let's go backwards now. So here, if I carry that on, I now know that C is 30. So 30 divided by 3 gives me 10. And we now know that B is 10. So now here, we can put B in there. So now we've got 10 divided by 2, which gives me 5. And I can add those up now because we're doing A plus B plus C. So we're doing 5 plus 10 plus 30. And I can show that there, 5 plus 10 plus 30. And it gives me 45. So I'm going to put that nice and large on there. Okay. Hope that makes sense. But 3-mark question, we've covered everything there. Question 12 is more shapes. But this time, we've still got a centimetre grid, which is important for us because we know that each one of those is a centimetre. We don't have to measure them, we take it as read. Okay. And we need to draw a right angle triangle with an area of 12 centimetres squared. So we know that a triangle is base times height divided by 2, and it's going to give us 12 centimetres squared. Now I know my base, it's 1, 2, 3, 4, 5, 6. So I've got 6 times something when divided by 2 gives us 12. So I need to get rid of that, so I double it. So I've now got 6 times something equals 24. And when I divide it by 6, I get 4. Okay. So that means my triangle must be 4 squares high. 6 times 4 gives me 24. Halved gives us 12. And it's a right angle triangle. So we're just going to pick, doesn't matter, whichever end you prefer. We just go 1, 2, 3, 4 squares. That's my height. And I just draw it across there. Okay. As I say, it could face the other way. You didn't need to do all of that. Again, that's just the explanation. Okay. Question 14. Money. Should be good with this. Everyone, most can deal with these. So at the moment, on Friday, Jodie has paid £98. So that is her wage for them, £98. We're going to assume that she gets the same hourly rate of pay on Saturday. And we need the total amount that she's paid for the 2 days. So we need to know what that total is. So to find that out, we're going to look at the same hourly rate. So we can take that 98 and we can divide it by the 7 hours. And that will give us her hourly rate of pay. So I'll clear off what we've done before. 98 divided by 7. And we get 14. So she's getting paid £14 an hour. And on Saturday, she did 4 hours. So we just do 4 hours times the £14 per hour. 4 times 14. And that gives us 56. So she's now going to get paid £56 for that. So we just need to add those two up now. 98 plus 56, and I put a times in there. Mistyped. See how easy it is. Right, clear that off. 98. I thought that was a bit high. Plus 56, and we get 154. That's a bit more like it. Although I'm sure as a weekend's paid, we would have preferred that first figure. So we've got that there, £154, and that's the whole weekend. So there, 154. Okay, so that's our answer there. But then for part B, one marker, tick the box. If Jodie gets a higher hourly rate of pay on a Saturday, what does this mean about the total she's paid for the 2 days? Well, let's face it, if she's getting paid more than £14 per hour, that means that 4 times higher than 14 is going to increase, so her total will increase. So it's going to be greater than the answer to part A. So question 15, P, Q and R are points on a circle and our centre is C. And we tells us that this is a straight line. So we've got 3 statements. And first one says PC is half the length of PR. Well, PC is a radius, PR is the diameter, so that one is true. It says QC is a chord. And QC goes from the edge of the circle to the centre, so that is a radius, not a chord. So that one will be false. Now, it then asks if the shaded section is a segment. Okay. And that one, well, it's not a segment, it's a sector. So that one is false as well. Now, I'll just explain that. The common ones that people get mixed up on are those. Okay. So if I was to draw a line across there, that line goes from one side of the circle to the other, but doesn't go through the centre. This line is the chord, and the section you get, that is a segment. Okay, and basically it looks like a piece of Terry's chocolate orange, so it's a segment. Okay, easy way to remember it. I hope that works for you. Question 16. We've got some information about pigs. So farm A has 630 pigs rounded to the nearest 10, and farm B has 600 pigs to the nearest 100. And then it gives us some information there. Okay, and then there's an extra question on there. So I'm actually going to go a bit more in depth just for the first part of it. Okay, now if we've got 630 pigs here rounded to the nearest 10, that means that there has to be a number that would round up to 630, but also a number that would round down. Okay, so in this case, because it's rounded to the nearest 10, half 10, we get 5. So take away 5, and then we add 5. So that means if the number was 625 or greater, then it's going to round up to 630. But if it's less than 635, it would round down. Okay, so that's the range, the error interval, the upper and lower bounds. Do the same for this one. Now we've got 600 pigs, and I'm going to put the same in there, but this time rounded to nearest 100. Half of 100 is 50, so if I take away on that side and then I add on that side, and again 550 or more is going to round up to 600, but less than 650 will round down to 600. Okay, we'll come back to that one a bit more in depth, but for now it says farm A has 637 pigs. Well, if we look at farm A, the highest it could be is less than 635, so that cannot be true. Farm A has 630 pigs. Well, that's what it's been rounded to, and we've got the upper and the lower bounds, but that doesn't mean, just because we've rounded to nearest 10 doesn't mean it wasn't already that. So that could be true. That might be true, as it says there. And farm B has 550 pigs. And again, same as when we look at the range, what we've got, yes, they could have had 550 to round up to 600. So again, might be true. So then the next one, next part of it, Jenny uses data from the table and says farm A definitely has more pigs than farm B because 630 is more than 600. And of course, if we look at those, 630 is more than 600, but when we look at the range, the error interval that we could have, the highest amount that they could have is less than 635, so it would actually be 634. And here, the highest would be less than 650, so that could be 649. So she is not correct. Okay, so we can say that. And we can say that. We could even say exactly what I've just said. The most that could be at farm A is, and what did we say there? We said 634. Farm B could be, and we said one less than a 650, so that could be 649. Pretty much anything along those lines. Now and again, I've written it like that. Please make sure your writing is clear and legible. I know mine isn't most of the time. Well, question 17. Ratio. We're going to be mixing syrup and milk in the ratio of 1 to 3. So I'm just going to put that there, syrup and milk, and the ratio is 1 to 3. Now we want that in, we want each milkshake to have 320 millilitres, but she has 0.5 litres. Now, there's 1,000 millilitres in a litre, so 0.5 litres is going to equal 500 millilitres. Okay, think about your bottles of Coke and things like that. You know, they're in down as 0.5 litres or 500 millilitres. Okay, so that means we've got 500 litres of syrup, so I can put that there. And of course, to get from there to there, 1 to 500, I've times by 500. So I'm going to do the same on that side, times by 500. So that means I need 1,500 millilitres of milk. Okay. Now, if I add those together, 500 millilitres of syrup plus 1,500 there, so 500 plus 1,500, and that's going to give me 2,000 millilitres of the mix. Now, good so far. We know that each milkshake should be 320 millilitres, so I need to find out how many times that goes into there. So I do 2,000 divided by 320. Again, we have calculators, let's use them. So we said 2,000 divided by 320, and I'm getting a decimal. So press your format button, down to decimal, and we've got 6.25. So that tells me that we have got enough to make 6 1/4 milkshakes. And the question was, does she have enough for 6 milkshakes? So yes. Okay, and we've covered that on there. Question 18, dealing with a bit of probability there. Okay, now at the moment the only thing we know is probability of red is 0.3 and we get 120 discs, and the probability of blue we don't know yet, but we get 60 discs, so we know 60 is half of 120, so we halve that probability and we get 0.15. The last one is a little bit more, certainly for the last part is a bit more difficult, but let's have a look at this. If it's probability in decimal, we know it must add up to 1. So 0.3 plus 0.15 gives us 0.45, and we take that away from 1, we are left with 0.55. But it doesn't help us with this. Now we can break these down and we can work them out, but let's have a look at this. If I do 120 divided by 0.3, that will give us how many discs in total. So let's clear that off. So 120 divided by 0.3, which means we've got 400 in total. So 400 discs in total, and of course our probability lands up to 1. So again, we can work out, we can add those together and take it away from 400, or we could just do 0.55 times 400, which I'm going to do now. So 0.55 times 400, and that leaves me with an answer of 220. So what did we say there? That gave us 400, didn't we? And I did 0.55 times 220. Sorry, writing the wrong thing down there. 400 equals 220. So that's just showing my working out, but as long as your table is right, you're fine with this one, okay? And of course, 120 plus 60 plus 220 adds up to 400. Now, question 19. As soon as they start throwing in formulas like this, people start switching off, okay? So I'm going to show you just how straightforward it could be. So C is the cost in pounds. That's what we're working out. I'm just going to write down there, our cost equals, and I go through each step, so 16 plus 7/10 of P. So that's 7/10 times P, okay? Because it's 7/10 of something, we're going to multiply that, okay? Now P is the perimeter of the frame in centimetres. And for perimeter, we add all the sides up. So the opposite sides are the same, so that's 24, that's 19. So let's do that one. So we have got, start off top corner, I've got 24 plus 19 plus 24 plus 19. So I get a total perimeter of 86. So I'm just going to put that there. So all I'm going to do now is I'm going to substitute that for what we had there. So if I cross that P out, I'm just going to substitute the 86 in there. So we can ignore that. Now we can type it in exactly as it looks there. Okay, and this is the trick. I'll clear that off. So I've got 16 plus, and then it's a fraction, so then we put our 7 over 10. Don't forget to move to the side, and then we're going to times that by 86. Okay, so it's basically, we're going to do, and the calculator will do it for us, it'll do 7/10 of 86, and it's going to add the 16. So we're going to press XE. Again, I get a fraction, so format to change it into a decimal, and we get 76.2. And of course, because that's cost in pounds and pence, then that will be £76 and 20 pence. Okay, always be careful with money. Don't forget, calculators don't understand the money, they just know the numbers. Okay, and that's what we're after for that. Like I say, that looks nasty, but we'll just type it in the calculator as it looks, and we'll get our answer. Now this one is a wee bit nastier than what we've had previous. Okay, so we've got profit or loss data for the first 6 years, and they want to know after how many whole years was the total profit greater than the total loss. Okay, so it's going to actually, so what I'm going to do, I'm going to zoom in a little bit on this one because it's not the easiest to read. There we go. So as we go through this one, so year one, we had a loss, we were basically at minus 24. Year two, we were at minus 10. Year three, we're into the positives, but this time it's a positive 6. Then we've got a positive 17. And then here, 5 years, we've now got a positive, where are we there, 27. And here, year 6, we are on a positive 38. Okay. Now, so we've read the table, we've got the numbers. Let's deal with the numbers. So in the first year, we're at minus 24, and just a quick check, it's in thousands. So we've basically lost 24,000 in the first year. It's, there's some go in that one. We lose another 10,000 in the second year, so that means we take another 10 away, so we're now at minus 34. In the third year, we start making profit, but we're still in debt. So we're going to be taking 6 off there, so we're still 28,000 below. The following year we make another 17,000 profit, so that helps pay off some of the debt. So when we look at that, so we just need to take our 17 off there. So we are on, let me have a look there. So it should give us 11, shouldn't it? Yes. So we're still at minus 11. And then we make positive 27,000. So we're going to add on to there. So we end up with, so we take 11 off our 27, we're left with 16. So that's going to be finally a positive 16. We're finally making money. Okay, so in debt, in debt, in debt, in debt, positive. So now we can say 5 years. So that's the idea of it. Don't think that just because the third year shows a profit that that's when they started making money, because there was money. Basically, they had to pay off. Basically, you think you start a business up, you get a bank loan, you owe the bank. And until you start paying all that off, you're not clearly in profit. Then the last question, use the graph to predict the profit for year 7. Now, if we look at our graph, it's an upward trend. And if I just go, you know what, I'm going to go right there. I think we're going to make a little bit more money there. Now, year 7, I come across there, I'm at 50, but don't forget, our scale is in the thousands. So I've gone 50,000. Okay, don't put just the 50, you will lose the mark for that one. Okay, sorry, knocking the camera there. And the beauty about that, because it's a prediction, pretty much they're allowing anything between 39 and 60 for the answer for this one. Okay, so I've gone sort of in the middle for that one. You could have been really cynical and said, oh, they're going to make a little bit more profit. It doesn't matter. Anything between those two, and of course, again, don't forget, that would be in thousands. So the mark scheme allows anything between those two. I've just gone slap bang in the middle. Okay. So, question 20. Sorry, 21. Town P and Q are 35 kilometers apart. On a map, the distance is 2 centimeters, and they want the form. Now, this is what we come back to, talking about ratio, the form of 1 to n. Now, so that means that the first number will be 1, and whatever we do to get that down to there will give us that. Now, it's scale. So at the moment, if I write that down, we've got 2 centimeters. So I'll put 2 centimeters and our ratio is 35 kilometers. Okay. But we need the final one to be in centimeters because it's got to be in the same unit. Okay, I'm going to put centimeters there. You don't have to, just to remind us. So at the moment we've got kilometers and we need it in centimeters. So the easiest thing to do, I'm going to change that. We're going to do 2 centimeters. I'm going to change it to meters first. So I'm going to do 35 times, now there's 1,000 meters in a kilometer, so it's 35 times 1,000, and we get 35,000, and that's meters. 2 centimeters will now be, and I want to change it into centimeters. So again, 100 centimeters in a meter, so I'm going to take my previous answer, I'm going to times it by 100, and I get 3.5 million. So we are now in the right unit, 2 centimeters to 3.5 million centimeters, but we need it in the answer of 1 to n. So that means basically to get 2 down to there, I'm now going to divide it by 2. So my answer divided by 2 gives me, it's 1,750,000 centimeters. And that is what we're after. And that's why it was worth 2 marks. Okay. It was working with the scale. And now we've got another transformation. This time it is a rotation, and it gives us the direction of anti-clockwise, it gives us the angle and it gives us the center of rotation. So 5 minus 1. So I'll come across to 5, down to minus 1. That is my center of rotation. So I'm going to use it on tracing paper. Now you always see, I've used it before. I always start off in the corner, make sure I've got enough room. So I know where my center is and I know where my shape's going to be. So I'm going to draw my shape out. Now, there's loads of different ways people do this one, and you just say, just put the pen there and turn it 90 degrees. The thing I do, just to help us, is I put across there, and that's in line with the grid. And we know that each quadrant of that grid is 90 degrees, and I'm going anti-clockwise, so I'm going back that way. So if I put my pen in the center, I can actually ignore my shape. I'm going to hold my pen on an angle so you can see this cross, because if I ignore the shape, I know if I start turning that, when that cross lines up again, that is going to be my 90 degrees. And there we go, there's our 90. So the top of my shape is there, and as we come back, I can mark off the rest. And of course, we still need to complete our shape. Now there's 2 marks available for this. So if you did misread it slightly and you went clockwise instead of anti-clockwise, you can still gain a mark. And if you misread this, the 5 minus 1, and you've just ended up with a shape rotated clockwise, and you've ended up, say for instance there, it still gives you the mark because you've rotated it in 90 degrees anti-clockwise, you just haven't done it from the correct point. Okay, so this is why we always say with these, try them anyway, because there's still marks to be gained. So 23, we've got a bunch of numbers. We've got 8, 15, 22, 29, and this time it's not asking us for the next, it wants the nth term. It's the rule for our sequence. So what have we gone up by between 8 and 15? We've gone up by 7, we've gone up by another 7, and up by another 7. Now I've checked that to make sure that it is. They've told us the linear sequence, but I want to make sure. Now if it's gone up by 7 each time, that means we've got 7 times the number of the term. But we still need more than that, because 7 times 1 is not 8. Okay, so with this time I'm going to go backwards to what we call the 0 term, and instead of adding 7, I'm going to take away 7. 8 take away 7 leaves me with a 1, and it's a positive 1, so that gives us 7n plus 1. And it's 2 marks. Basically you're dealing with a mark for each part of that. Okay. Then we've got a different nth term. This time we've got 2n minus 3. So 2 times the number of the term, take away 3, will give us our answer. Okay. Now they want the position of the term, so they want to find out n. So the position in the sequence, that is the first to be greater than 100. Now the greater than 100 is more than 100, so I'm going to pick the next number that is there. So I'm going to go with 101. So if 2 times something minus 3 gives us 101, I can now solve it. So I'm going to do the same. I'm going to add 3 to both sides. So the plus 3 and the minus 3 cancel out, so I'm left with 2n now equals 104. And because it's 2 times something, I'm now going to divide by 2. So that means that n is going to equal 52. So we know 2 times 52 gives us 104. Take away 3 leaves us 101. Okay, so it's the 52nd term that we're after. Okay. So we get rid of those. And this just looks nasty. Let me zoom out a little bit. So we've got the graphs of y equals 2x plus 1 and y equals x minus 1. And it wants us, and this, the wording, use the graphs to solve the simultaneous equations of y equals 2x plus 1 and y equals x minus 1. It's worth 1 mark. Okay. To solve the simultaneous equations, basically we look at the two lines and we find out where they cross, which is here. And we put the coordinates down. So it's -2, -3. And that, would you believe, is it. Okay, that's a lot of information for 1 mark. And again, people see simultaneous equations and just think, nope. But where the lines cross, that's what we need. Now this one was a nasty one. We want 2 triangles that must be congruent. So we are looking for 2 triangles that are the same angles, same sides, but they've been really sneaky. Now remember, congruent means they can be rotated and they can be flipped. And the 2 that we're after here are actually A and D. And if you look at those, you go, well, they're not the same. But if I was to flip this over, the 7 side is there, the 9 side is there. So that would mean that this angle would be 52 degrees. Because it didn't give us any of the other angles, didn't give us the other side. We don't know anything else about the triangle. Not drawn accurately, as they always say. But if I added those up, 78 plus 52 plus 50, I'm going to get my 180. So it is, as we say there, A and D. And I haven't circled there. They do accept it circled on the diagram. But I think, let's do it there anyway. A and D. Okay. Horrible one, that one. And that brings us nearly to the end. Here we've got, basically it's a double inequality. So we're saying x minus 1 is greater than 4, but it's also less than or equal to 11. And we want all the values of x. Now, I just write that out a bit larger there. I've got 4. So we know that x minus 1 is greater than 4, but it's also less than or equal to 11. But we want x on its own. So the first thing I need to do is I need to add 1. But I need to do the same everywhere. Okay. So we've now got x on its own is greater than 5, but less than or equal to 12. And it tells us it's an even whole number. So it's got to be greater than 5. So the next whole even whole number there is 6. It could be 8. It could be 10. And it says it's less than or equal to 12. So we include the 12 there. Okay. And that's why it's worth the 3 marks. It was just that extra step. Basically adding 1 to each to get x on its own. Okay. So a building's got 36 flats. So number of flats, that's going to add up to 36. Just making a point of that now, because it says show that the mean number of people per flat is less than 3. Okay. So for this one, basically, we know if there is 3 flats with 1 person in, that means, well, 1 times 3 gives us 3. We're going to do the same for each now. 2 times 10 is 20. 3 times 17 is 51. And 4 times 6 is 24. Okay. So basically what we're saying there is if you've got 17 flats with 3 people in, that's a total of 51 people. And so on for the rest of it. Okay. So we need to add those up. So 3 plus 20 plus 51 plus 24. And that gives me a grand total of 98. So 98 people in 36 flats. So 98 divided by 36. And again, I've still got my answer there, but let's clear it off anyway. 98 over 36. And I get a fraction, so press format down to a decimal. And we've got 2.722. Now, there's lots of 2's there, isn't there? Just a quick word on this one. When I press format, you've got decimal, but it also shows recurring decimal. And it only shows that if it is a recurring decimal, something handy to remember. Okay, so if I press OK there, I've now got 2.72 recurring. and that's 2.72 people. You can't have 0.72 of a people, so it is less than 3. That's fine, we've done it. Okay. 28. We need to find, so we've got students at a school, and whether they prefer science or English. And obviously the correct answer is they actually prefer maths, but yeah. And what percentage of the students at school prefer science? So that's what we're going to work out. So we've got our table there. First thing I'm going to look at is the total number of students. So I can clear that off. I do 225 plus, we said 975. So that means the total number there is 1,200 students. And we need to find out, basically we need to get a third of 225 and 3/5 of 975. So again, we have a calculator, let's use them. So we can put 1/3 times 225. That missed out my multiply sign, go back, put it in. It would have come up syntax error then if I missed that out. And we get 75. So that's 75 of the year 11 prefer science. Do the same again. 3/5, move to the right and multiply by, and this time 975. And we get 585. So that's 585 prefer science in the other years. So we add those two together. So we've got 585 plus my 75, and I get 660. Now that's 660 out of the 1,200. So we can change that into our percentage. We can put 660 over 1,200 and then times it by 100, and that will give us our percentage then. So clear it all off. 660 over 1,200, move to the right and times by 100. Quick check on the screen, yes, that is correct, and we get 55. And that is our percentage. 55% prefer science, and we can drop that in there. There's our answer. Okay. And this is what catches people. I think 4 marks, got to show everything. Basically, I've worked out the total, I've worked out the fractions and the total for the ones who prefer the science, and then I've found my percentage. So even though I've shown it next to the table, there's the evidence is there for what it's done. Okay. And then on to question 29. I can turn that page, and this is our last. And they've saved a good one for last. So a track is a circle diameter 15 meters, and a horse runs at an average speed of 6 meters per second. We want the time in seconds the horse takes to run around the track. So circumference of a circle, we want pi d. So I'm going to do pi times 15, which is our diameter. Now that is going to give me 15 pi. But let's show it on here anyway. So pi on these calculators, we press shift and then 7. We can see the pi there. So pi times 15 gives us our 15 pi, as we say. And I'm going to just put it in brackets. If I change that into a decimal, I've got 47.1238898. Now, we're mid-calculation here. We don't need that. So I'm going to say, leave it as standard for now. Leave it on the calculator's 15 pi. Now, the horse runs at an average speed of 6 meters per second. We've worked out how many meters there are, so we take that, and I'm going to use it in here. I'm going to do 15 pi divided by 6. We could have also done, and I'm going to put it in the brackets there, we could have also done 47.12 so on divided by 6. Okay, so 15 pi. Now there's my answer, so I'm just going to put divided by 6, and that's going to give me, that gives me that. So we've got 5 over 2 pi And now, because I do want the seconds, I can press format and change it into a decimal. And what I get is 7.85 seconds. Okay. It says give your answer as a decimal. Now, I've put it as 7.85. I've rounded it 2 decimal places. It just said show it as a decimal. Okay, so you do want at least one. I know on the mark scheme, effectively, they've got 7.8 to 7.9, and anything between that one. Okay, so if you'd rounded it, so at the moment I've got 7.85. If I'd rounded that to 1 decimal place, we'd have had 7.9. So they didn't give us a specific rounding to do, but let's make sure it's right when we do it. Okay, and that's the last bit. Hopefully it's been useful, and hopefully we've learnt a lot this year, and we found these useful. That's the main thing. I'll keep doing them if they are. And good luck.